What's up, MEWC fans? Today we're going to try to do a complete case walkthrough using Python only. I'm pretty new to Python. I just started learning about a month ago, so this is going to be kind of rough, but I've already done a walkthrough before, so it's not like a real live attempt. I'm not trying to fool anybody here, but I'm still brand new at this stuff, so chances are we're going to have some rough patches. Anyways, today we're doing Sommelier, the case number 2 on the road to Las Vegas from last year, written by Pierre Charles. In this case, we have a couple tables of data, one for customers, which we will create a table out of. We'll call it customers. And we have a table with the wine data, which we'll call wines. And with that, we start our Python. I like to, right at the top, create a little place where we bring in our data to begin with. So wines equals, using the Excel method, wines. We want to do the headers as well. So make sure to put the all tag on there. And we'll do the same thing for customers. All right. So that's our data. And then we'll start with level 1. We'll skip the bonuses and do this at the end if there's time. So at the very beginning of each one, I'm going to create a function that's just called level X. And then put in the parameters that you feed it for each level. So this first one, we're just doing a lookup of the wine, of a wine and an attribute for that wine. And so we can just do wines.loc method and say wines.name equals your wine. And you're going to return the attribute values. Okay. And then we'll just name this level 1 solution for housekeeping. To call this, we're going to say level 1 and then pass wine and an attribute. And change this to Excel value. And we have a right answer. So far, so good. Now, across each of these levels, once I have the right answers, I'm going to copy and paste values just so we don't have Python recalculating everything every single time. Next, level 2 equals pi. Define level 2, customer, wine, and attribute. Now, what do we need to do here? It looks like we now have to look up the customer preference as well, subtract it, and get the absolute value. Okay, so customer preference. We're going to look up in the customers table. And we're going to say customer dot name equals customer. We're going to return attribute again. Values. Right? And then the wine attribute is going to equal wines.loc. And it's going to be wines.name equals wine. Returning the attribute column. All right. And now we're going to return the absolute value of customer preference minus wine attribute. Level 2 solution. So equals pi level 2, customer, wine, and attributes. And change this to Excel value. Well, we are flying so far. I mean, this is still way slower than if we were entering formulas, but you have to start somewhere. So level 3. Oh yeah, let me copy and paste all these. Okay. Equals pi level 3. Define customer attributes. Okay, so what are we doing? We're going to look up the scores of every wine and see which one has the lowest. All right. So we're going to use that level 2 function we just wrote. I'm going to create an empty list called scores and then do a list comprehension. So we're going to say for each wine in wines.name, singular score equals level 2, which needs a customer, a wine, and an attribute. And then we'll append that to the scores list. So now we've got scores. Now, there's probably a better way to do this, but since I'm accustomed to working with data frames so far, I'm going to convert this list into a data frame. And maybe Owen will tell me the best way to do this, or some viewer will tell me the better way to do this. So we're going to convert this to a data frame, scores, and I'm going to get the index of the lowest value. And I'm going to plug that into wines.name.iloc. iloc is like loc, but it works off the indexes instead of the names. And I think that's probably it. I might need to put values on that. Let's see. Oops. Meant to give it a label, level 3 solution, and then say equals pi level 3 change this to values, and we have an error in this cell over here, invalid syntax on line 3. So for missed in. We still have a Python error. What's the error? Busy. It doesn't show me the error. That's irritating. Unhashable type series. Unhashable type series. Okay, I think this IDX min needs to be called like that. There we go. Change this back to values. And let's see if we get a spill range. We do. So this is returning the whole series, including the header. So we're going to return just the values. And that's good. All right, copy and paste values. Moving on to level 4. This is actually going not bad. Pi define level 4 as customer and wine. And what are we doing here? The sum of the absolute values. All right, so customer preference is going to be customers.loc, and we're going to look up customers.name, and we want to return just the columns that have the values in it. So we're going to say customers.columns and use a slicer to say everything after the second column, or starting with the second column, sorry. And then the wine attributes. Similar idea, but one slight difference. is that the columns of the wine table has an extra column called price at the end, and we don't want that in this context. So we're going to actually just go 1 to 6 on that one. Okay, so we've got customer preference, we've got wine attributes. So we want the absolute value of customer preference minus wine attributes dot sum. Okay, and this is level 4 solution. So we say equals pi level 4, boom and boom. Change this to values. Cross our fingers. Ooh, right answer. This is good. Copy and paste. So 1 through 4 down. All right. So with level 5, we're going to get the best wine for the customer using the methodology of level 4. Okay. So we're going to say equals pi. Define level 5 as just customer parameter. And then we're going to say scores is an empty list. And we want for each wine in wines.name, we want to get the score. So individual score, this is scores, individual score equals level 4 customer wine, right? And then with that, scores.append your score. So just like before, we're going to do this data frame thing. So we're going to go wines.name.iloc. And we're going to say panda.dataframe scores dot idx min, like that. And which column? That's it. That's all I need. Dot values. I think that's all we have to do. So level 5 solution equals pi level 5 customer. Change it to cell value. Not bad. Not bad at all. Copy and paste values. Alright, so level 6 is like level 5. The difference is instead of adding the absolute value of the raw scores, we're going to plug it into this table and get like this version of the score. Okay, so that's what we're doing. Now, equals pi. In this one, we're going to need to refer to this table. So I'm going to give it a named range called score table. And then at the beginning of my Python here, we'll make a data frame out of it. Score table equals, like so, score table. No headers on that. All right, so now we define level 6 customer and wine. All right. So our customer preferences, we've done this before, is going to be equal to customers.loc, customers.name equals customer, and we're going to return customers.columns, like that. Okay, wine attributes. In fact, we can just copy and paste from up here. I think it's going to be the same. All right, but instead of returning the absolute values, we need to look up the absolute values. So this is just going to be raw score, not dot sum. So for each raw score in raw scores, let's do something. Let's look up. So how are we going to do this? We're going to look up score table loc score table 0 is less than or equal to raw score. Okay. And then I want the maximum value of that. So score table dot loc 0 dot idx max, and then look that up. Score table two dot iloc dot values. So the adjusted score equals that. Scores dot append score. And now it's just some scores return. Level 6 solution. See if we get lucky on this one. No, we did something wrong. Over here, unmatched bracket on line 8. Unmatched bracket over here. So IDX max. Okay, so what's going on? Right here, we don't want that one. This still has an error. Doesn't tell me what the error is. Customer preference is not defined. Customer preference. Because we called it customer preferences. So picky, Python. Still an error. Raw score is not defined. Raw score is not defined. Where are we using capital? Oh. Lengths must match to compare. Lengths must match to compare. I have a feeling it's in this line here somewhere. I'm going to do a little bit of debugging here. So print raw score, print this part, print score table 2 see what happens with that. Okay, so it prints the first line, the first print, but fails on the second. So here, it doesn't like something in this area here. This raw score. Oh. So raw scores here, though. Let's try that. All right, no attribute values on this right here. Oh, we got there finally. We got there finally. We don't need the printing anymore. Okay, copy and paste that. All right, those are good. Level 7. The best wine will be the one with the lowest total score. So we're just using the scoring methodology of here. So that kind of mirrors level 5. Let's copy level 5 and say equals pi. Change this to level 7. And we're using level 6 scoring instead of level 4. I bet you that gets us our answer. Equals pi. Level 7. Change. Damn. That was good. Alright, level 8. Level 8 will be the one with the lowest adjusted price. The wine's adjusted price is the wine's price plus $5 times the wine's total score. Okay, so we can get total score using level 6. Otherwise, it's the same logic. I think we're just going to copy and paste this. See if this works. Alright, level 8. Level 8. Okay. So the only difference here is that we're going to call this adjusted price. The score is still the same, but the adjusted price. Okay. Here, we need to get the price first. So the price is just the wines, filtering what wines.name equals wine, returning price. Okay, so that's the price of the wine, that's the score. So the adjusted price equals price plus 5 times score. So adjusted prices dot append with the adjusted price. Okay, now we're good with that. Equals pi level 8. Change it to values. And we're good. I did not expect to finish all 8 levels in 30 minutes this time, but we got there. We may even have a little bit of time for bonuses. Let's see. So the thing with Python on the bonuses is that if we want to use anything that we've written, we need to bring this down. So I'm cutting all of these rows and bringing them down to the bottom. All right. How many customers are not listed at all in levels 2 through 5? So one of the things I don't like about Python is that in order to pass it any sort of data, I need to give it data from a range. And in this situation, I would love to just be able to pass it like a formula with a V stack or a H stack or something like that. So we have to get all the values of these customers from levels 2 to 5 in a cell or spill range here. So we're going to say equals 2 row V stack, and we're going to get customers from 2 to 5. Okay, so starting here, we want these customers and these customers and these customers. These customers. Okay. And so there's our customer. So this is our data range for this cell. So we're making a list of the used customers. And then we're going to use the is-in feature of a data frame. So we're going to say customers dot name dot is-in used customers dot to let's see, use customers dot iloc 0 to list. And we have to do that because the is-in feature you can't put a data frame in there, so this has to be convert to list first. That should give me a list of true falses. Yeah, and so now we can plug that in using customers.name.loc and say we don't want it to be in there, and then get the size. Good. All right. Across both customers and wines, there's one attribute which appears the most. Which number is that? Okay. So equals pi. Now, the way that you stack data frames is the concat. It's like this: pandas.concat, and then you give it a list of data frames. So wines and customers. Okay, so that adds them together column by column. We don't want all the columns. We just want 1 through 6. So all rows 1 through 6 is your columns. Okay. And now there's still 6 individual columns we can stack together. Now let's just see where we're at so far. I think we should have a single column series. I didn't expect the labels here, but maybe that's how stack works. Still says about 1. So these are the values here. So that's still fine. What is it we're trying to do? Get the most common one. Well, that's just mode. Yeah, and then it changes to values. Should be correct. Good. All right. Now, if you were to apply level 5, I made some mouse issues. Okay. If you were to apply level 5 rules to determine the best wine for all customers, there is one wine which is best for the most customers. Okay, so level 5 returns the best wine. So we want to do that for all of them. So we're going to say equals pi, and we're going to go customers.name.apply level 5. Okay, what do we get there? Should have a list of wine names. That's a series. Okay, a series of ND arrays. Actually, a series of ND arrays. Kind of didn't expect that. What if we can do values? Flatten. Let me see. Can I turn this? I need to flatten this somehow. Should copy paste these values so it doesn't take so long. There's no attribute to list for an ND array. So about that? This is a series, so toList may work for that. But then am I just going to get a list of ND arrays? This function takes a while. Okay, that's great. So I got that to a list. Now I can use, I know there's a better way to do this, but right now data frame is my tool and everything is a nail. Sorry, data frames are my hammer and everything looks like a nail. So I happen to know that I can use mode on a data frame. I don't know how to get the most frequent answer out of an ND array. So I'm doing all this conversion, probably unnecessarily, but that's just due to lack of familiarity with all the methods. Right, that should be our answer. All right, riddle. What do you call an Excel sommelier? Okay, the answer is given by offsetting the first letter of the answers for games 127 and 140. Okay, so I'm going to say equals pi. Let's bring in those answers. Answers equals here. Now we can turn it into a string and take the first character. So let's see what we get there. Should be a bunch of letters. Oh, it's an error. Data frame object has no, okay. Data frame object can't do this directly, so we're going to go turn it into a series first by saying 0. I think. Yeah, since we didn't give headers, 0 is the name of the first column. And this gets us our first letters. Okay, good. Now, so to get the Unicode, there's an ORD function, I guess, for ordinal. Now, I guess it's not going to work. ORD expected string of length 1, but series found. Okay. So doesn't want to operate against this whole series. So what we're going to do instead is list comprehension, I suppose. So for answer in answers, print org answer. See if this, okay. All right, that seems to get what we want. All right. So now, we need to create, let's see. So ord answer, now let's subtract 64. Okay. And I'm going to try something a little fancy here. We're going to go index answer in zip. I want to say it's like range. $127, $140. I don't know if this is right. We're going to find out. Print index. Probably messed that up. Certainly did. Type range is not subscriptable. I don't know what that means. Can't use range. Can I use answers index? Yeah, I can. And now let's add 127. Okay, so index is the 127. All right, so I want to say add the index, subtract 1, and then mod, which is a percent sign. Mod what? What am I modding? 26. And then wrap that, add one back to it. Let's see what we get here. Yeah, it looks right. So we're gonna put CHR here. No, that does not work. CHR. Why not? Let's try it again. What do we get with this? Yeah, look. These all look good. Is CHR the wrong thing to use? Thought that would work. I thought that would work. Oh, I know why. I have to add 64 to these things. Aha! So let's see. I think maybe if I do this and put this in like a list, I might get a list of characters and then dot join. No, I know. It's empty string dot join like that. Haha. Winner, winner. All right. Using the level 8 approach, what is the most expensive adjusted price across all possible customers? All right. So level 8 was looking for the lowest, and it uses the level 6 scoring system to do that. And so the level 6 score here returns well, this just returns the overall score. It doesn't actually, so that's good. It's the level 8 part where we're looking for the min instead of the max. So we're going to repurpose level 8 solution. So equals pi. We're going to rename this bonus 5. So bonus 5 is for is for a customer. Okay, so we want IDX max. Yep. So this returns the wine that's the max. We don't want to return the wine though. We want the actual value of the max. So that would just be adjusted prices. Max of adjusted prices. Okay. And then we're going to say, so prices equals, and then we're going to say for customer in customers.name price equals bonus 5 customer prices.append price. Okay. And so you've got prices and you want to return the max price. Max prices. All right, let's see. Takes a long time. Need that premium compute. Need that premium compute. I feel like this better be right. I think we got the right answer, but now it's going to take a while to recompute there. Definitely feel like my Excel formulas perform better than these Python code, but that probably is just a factor of the way I'm writing it, which admittedly is not the most efficient. Okay, finally got there.